problem is there's many ways to do it. There's lots of different strategies. Some people did complex strategies, and some people did simple strategies. And all of those strategies are fine, as long as you know what you're doing and why you're doing it. Most grade 2, 3, 4, actually up to grade 12 students, 11 actually do not do substitution or elimination, but if you want to do a system of equations, you could be a gifted junior high or elementary school student. We don't actually teach systems of equations until beginning in grade 10 and then into 11, 12. So somebody tell me how you did it. How'd you do it?
I divided both numbers by 2.
You divided both numbers by 2.
That was just to save me time. I was going to multiply by 2 right after I was finished.
Okay.
And then I drew 17 circles.
That gave you 17 and 10. That gave you 17 and 50.
Yeah.
Okay.
So then I drew 17 circles. And then I put 2 dots in each of them, and then continued with 2 dots into the next one.
Can I put 2 lines?
Yeah, that's fine. So I counted up to 51. 15 dots.
Okay, right now you have 34. Right?
Right.
So then what did you do?
35, 36.
And you put 2 on it, right?
Yeah.
Okay.
37, 38. 39, 40. 41, 42. 43, 44. 45, 46. 47, 48. 49, 50. And then I multiplied that by 2.
Okay. So,
it was 8 times 2 and 9 times
okay, good. So you get 16 and
2. 8.
18. So 16 horses and 18 chickens. Did anyone do it like this but drew all 34?
Yes.
Yeah. Most little kids will just draw all 34, right? You're just trying to make your work easier, which is good, because you know that you cut it in half and then double it again. Okay, because both the numbers were even. So 17 animals use 50, then 34 animals use 100 legs, right? So this is actually a very efficient strategy. It might seem kind of silly, but it's actually faster to do than the algebra. Now, this table over here did algebra and drawing the picture, and the drawing the picture got done before the algebra, right? Okay, so a lot of kids will just draw 34 bodies and make them all chickens, and then use whatever horses or legs that are left over to make horses, right? Which is actually an efficient strategy. If I was really nice, which I'm not, I would have given you stir sticks or toothpicks to use as legs and little counters to use as bodies. But I knew that you didn't really need that. But for grade 2s, they might need that, right? So they might use like actual toothpicks as legs and little counters as bodies and sort them all out, match them all up. Okay, which is the same as what you did with your picture. Did anyone do it using kind of like
Trial and error.
okay, what do you mean by trial and error?
Like we did, let's see. We did like 17 chickens and 17 horses. 17 times 4, 68. 17 times 2, 34. No, didn't work.
Okay, so 17 times 4 is 68,
Yeah.
and 17 times 2 is 34. So if they were half and half, which is a good place to start, right? But you have how many legs there? 102, that's too many.
Yeah.
So what did you do then?
Then we tried.
You just need to take a horse and make it up chicken, right? Because how do I get rid of 2 legs while I turn a horse into a chicken?
Yeah.
So then, it's not very often you hear that in every day, huh?
There's a lot more.
You did it, you just kept going?
Yeah, well, we didn't start with 17 and 17.
Right.
But yeah.
Okay, Okay, so then you do 16 horses, each have 4 legs, so instead of 68, you have 64. And then you increase the chickens by 1, so 18 chickens, each have 2 legs, which is 36. And rejoice and be glad, we have 100 legs. Jody, is that how you did it? Kind of, sort of? Some variation thereof? Okay. Another strategy is just to think, well, what if they were all chickens? Okay, that's another strategy. Let's go with my what if they were all chickens first. Whoops. If they were all chickens, I would use how many legs? 68. Which means how many extra legs do I have? How many horses can I make with 32 legs if they already all have 2 legs? 16. Because I need 2 more legs to make a horse. Right? So I need 16 horses and then 18 chickens, because that goes with 30 chickens. Okay? So 34. Okay, so that's another way to reason it out. Now what's interesting is if you give this problem to a room full of high school math teachers, in a room full of half high school math teachers and half elementary teachers, the majority of the elementary teachers finish it first. Because the high school teachers, once they learn algebra, forget that it's not always the most efficient strategy. So how many people did this? And then you can solve this either through substitution or elimination. So I might solve for y, make y equal to 34 minus x. And then I can substitute this in for y in this equation. So I get 2x plus 4 times 34 minus x equals 100. Then I get 2x plus 4 times 34, which is what?
106.
Thank you. And he's hungover. I have to take on you at least 10 times now.
That's okay.
Okay.
I was in Vegas, that's
Yes, and I wasn't.
Yeah.
So. Okay, so then we need to solve that equation. So we've got 2x minus 4x is negative 2x. Oh yes, so now we're using negative numbers, which is, you know, most grade 3s know that. 1 equals 100. And yeah, we need to kind of expand our page here. No, you don't, because proper algebra says we must add 2x to this equal plus 136. Oops, I forgot my 1. Equals 100. Ignore that my 3 has 3 loops. Minus 2x. Oh no, plus 2x. Sorry. So now those can cancel each other out. We have to keep our equation balanced.
Well, yeah, but you could also just put the 136 here to 7 and 1 and 2 left.
You will not get full points on your grade 12 provincial exam if you skip steps. Now you also won't get points for this, but I'm going to do that anyway, because they'll say, is that an exponent? They'll take points off of that, swear to God, true story. Yep.
I didn't do them because I got
In here, everyone has to do.
Now they do, yeah.
So then we have 18 is equal to x. And now we need to still solve for y, which y was 34 minus x. Oh, 34 minus x So y equals 34 minus 18. So y equals 16. But again, we won't get full points unless we verify that. So we need to verify, because we won't get full points. So we need to show that 2 times, what was y? X? What was x?
X plus y equals 34.
No, because that's what we use to substitute. We have to check it in the other equation. What did we say x was? 8? I think I lost my connection. It's okay. It'll come back. It's coming back. So 2 times 18 plus 4 times 16. Okay, so we have to do that, and we have to show that that's equal to 100, right? Because we can't assume it is. So then we get 36 plus 64 is in fact equal to 100. Doop, doop. And then we put 100, and then we have to say Q, E, D, Kid, S, Domine. It is demonstrated. And it took us 4 pages to do what the grade 2s did in one little drawing of circles. Okay?
These are really big though.
I did. It's really hard to write with the little style. But the point is it takes considerably longer to actually do the algebra. Now, if I'm teaching the grade 11 chapter 1 on systems of equations and I want them to solve it using a system of equations, using either substitution or elimination, then I might give them this problem and get them to do that. But then it just becomes an exercise of whether or not they can actually execute that solving an equation by solving a system of equations. Okay? If I'm just interested in getting them to solve the problem, then actually just using a guess and check strategy or a calculation strategy or drawing a picture is way more efficient than using the algebra. Okay? Now, this problem is a special kind of problem. It's called a level 3 problem. And the reason it's called a level 3 problem is because there's no clear kind of path to how you get the answer. You have to figure it out. You have to use problem-solving strategies. So some of our problem-solving strategies are make a list. So some people might have made a list or a table, right? You might have started doing like legs and horses and figured it out. Guess and check. But it's not just any old willy-nilly guess and check. It's sort of like, oh, okay, I did this calculation and I'm off by a bit, so now I'm going to adjust it, right? Draw a picture is a good strategy. Use algebra as a strategy. In this case, it wasn't the most efficient strategy, right? But whenever a problem requires us to kind of look at it and figure it out, and figure out how to do it without having a clear path or a plan, that's what we call a non-routine problem, okay? And we want kids to do lots of problem solving. And so this is a level 3. There's no clear path as to how to get there. And we want to give kids, about 25% of the assessments that we give kids should be at the level 3 level. So multi-step, multitask, open-ended, kind of, you have to go in and figure out and use your problem-solving strategies to get there. Okay? So I wanted you to have that experience of being good problem solvers. I also want a laptop that doesn't turn itself off every afternoon at 3:40. But I don't think that's gonna. Every day at the same time, it turns off the internet. Just like, done. It's so bizarre. Okay, so today we're going to talk a little bit about assessment. And we're going to talk about kind of how it works and a little bit about levels of questions. And then I'm going to actually get you to take some laptops, look at some curriculum documents, and write some good assessment questions. Okay? But you've probably learned a little bit about assessment in P&P. If I know Elizabeth, she talks assessment a lot, right? No, not really. because she's saving it all up for later. But when we talk about assessment, we kind of are always going through this cycle. Every time we give kids something to do in math class, it is an opportunity for us to assess, right? That's why we don't want them watching us do math. If we're standing at the front of the board doing a whole bunch of problems and their job is to watch what we do, what are we assessing? How well they listen? How well they watch? Right? We need to give them tasks that allow them opportunities to show us what they can do, right? Or allow them opportunities to discover the things that we want them to discover. And our job as teachers is to notice and take that information and use it to plan the next thing. So assessment is something we do every day. A lot of people think assessment is the end of the unit, you give a test or an assignment or something. But that's assessment of learning, that's the end of the unit kind of stuff. But we are talking more about assessment for learning. So I need to always be monitoring and figuring out what my students are doing and then using that information to plan tomorrow. So even though we might have kind of a map laid out of where we're going through the unit, we also have to be open enough that sometimes we just stop what we're doing and fix a problem if we notice a problem, right? Stop what we're doing and go back and revisit a concept if we find kids are stumbling over it. And the higher up you get, the more often you'll have to do that. I used to find that a lot teaching middle school, that there were a lot of times when I had to stop and rebuild a concept because kids didn't have it solid, right? So when we're planning, right, we plan assessment criteria. And you've already done a little bit of that when you were doing your lesson plans. You looked at the outcomes and said, what would I need to see in order to know that kids have met this outcome, right? So if I look at an outcome, maybe I'm looking at understanding meaning of multiplication in grade 3, which we've just been talking about in the last few days. So they need to know how to do area models and set models and linear models, and I know all those things. So I'm going to look for all those things, but I'm going to plan opportunities for them to show me all of those things. So I might have a bunch of learning centers set up, like we did the first day we did multiplication, where they build sets and they do jumps on a number line and they build arrays with square color tiles. And I want to make sure they understand that when they see 3 times 4, it can mean all of those different things, right? So I want to be clear about what I'm looking for, and then I want to gather some evidence. I want to either have a little observation and go, oh yeah, that student's getting it, this one's not. Uh-oh. Right? I might have them pass things in. So evidence is often, you'll hear conversation, observation, and product. Right? So you get evidence from those 3 means. I might have a conversation with a child, which can be just having a conversation with them, talking to them. But it might also be them writing about something. That's usually a conversation task as well. If they explain, like maybe they do a journal where they say, you know, respond to some kind of a prompt, like one thing I know about subtracting 2-digit numbers is, right? So that's a conversation. Observations are the things we do as we go around the room, right? What do we notice? What kind of models are kids liking? Which ones are they not liking? Can they do the number line versus the base 10 blocks? Things like that, okay? And then products is kind of the typical things we think of. Anything that kids pass into us, any presentation or any kind of, well, presentation could be communication. Any kind of product that they pass into us. So we collect evidence, right? And then we make decisions based on that evidence. Sometimes it's like, uh-oh, I need to go back and reteach subtracting 2-digit numbers with grouping because got some crazy ass answers going here, right? And that happens quite often. Sometimes you'll notice that kids make the same mistake over and over again. If you have like 5 or 6 kids in the class, they're all making the same mistake. That's an indication that you need to go back and do some more planning, right? You need to go back and think, what can I do, right? And you use your evidence to make decisions. So this is kind of basically what we do every day. We plan a task, we notice what kids are doing, we gather some of that evidence, we record it in some way, right? And then we look at it and think, what does this mean for tomorrow? And then we make some decisions and we start planning again. And this is kind of the cycle of our lives in education, right? Now, with assessment, there are lots of different purposes for it, right? Sometimes, most of the time, it's about this, promoting student growth, right? A big piece of what we do is we want to see where students are, know where they need to go, and figure out how to help them to get there, right? That's kind of, if I had to sum up teaching in an expression, that's kind of what it is. We see where you are, we think about where you need to go, and we think about how we get you there. Sometimes it's not that far, sometimes it's really far, sometimes it's a straight path, sometimes it's a really convoluted path. Okay? So most of what we do is about monitoring student progress, looking at how they're doing, and then thinking about how to help them to improve. Sometimes it's about making instructional decisions. Sometimes we go, wow, they really don't like those two-color counters. I'm going to have to find another model to use, right? Or, oh, they really didn't like the number line. I really need them to learn the number line. How can I make it more interesting for them, right? So sometimes it's about improving our own instruction. I always said that every time I failed in teaching, which I did often, because there were lots of days where,
What?
well,
I believe it.
lots of days where the lesson just went really badly. It's funny because I had a student in the ed program a couple of years ago who was my student in high school. And I was saying, well, when I taught, I did learning centers and all this kind of stuff. And she looked at me and she said, when you taught, when? I was like, after you, I got better. Because I taught her like my first 2 years of teaching, or 3 years of teaching. She was in grade 10 when I started teaching. And so I taught her 10, 11, 12. And I did get better after that. But really, every time your lesson fails, there's two ways you can look at it. Some people will do this. These kids are all stupid, I don't know why they can't get it. You've met those people, right? Other people will go, wow, what did I do wrong there? And I better try and do something different tomorrow. And that's what good teachers do. They learn from their mistakes. You will make mistakes. You will not be perfect. It took me a long time to figure out how to teach, and I'm still learning new things all the time. Right? I think like every time I go into someone's class and do a lesson, they're way more interesting than they ever were when I was the actual classroom teacher, which makes me seem like a fun math lady. But you'll learn as you go. But a lot of the time, it's about being comfortable enough to say, it's not them, it's me. Right? Sometimes the things you learn don't work. And that's why we try to teach you lots of different strategies. And sometimes you'll be like beating your head against the wall because you're like explaining it and you're using all your best stuff and it's still not working. But that's one of the things that's interesting about teaching is that it's like constant problem solving every day, right? So if it didn't work today, go try something else tomorrow, right? And that's a big piece of what we do. And we have to be open to that. That's why we make you set professional growth targets when you're out planning, right? In the field and stuff. Because we want you to think about what can you do to improve to make the experience better for kids. And it's something that I'll tell you that I learned more from my students just because sometimes it didn't work. And as long as I was open to listening and realizing that I wasn't, like, it wasn't me, I wasn't a failure, but the lesson was a problem, and that strategy was a problem, so I needed to find new strategies, right? And that's the things that we need to be open to. We can't kind of say, this is the way I'm teaching, and if you don't like it, too bad. If you can't learn it, oh well, you're not smart enough. A lot of high school math classes are still like that today, right? There are a lot of high school math teachers who think that if you can't keep pace with me, then you should be in the foundations class. You heard that one? Yeah. There are 5 different levels of grade 10 math in this province. 5! It's insane. Okay? And it's not because it's necessary. In fact, every study ever done about streaming shows that it doesn't work. It doesn't work. Every study shown with mixed ability groupings shows that it benefits all learners.
So why do they have the streaming?
Because teachers don't like to differentiate, and they want it that way. Tradition. Right? If you're not open to varying your methods, then you're not going to reach those kids, right, that need a different approach. But every study in the world has shown that mixed ability groupings benefit all kids, and that streaming actually lowers the grades of all kids, even the top kids. The top kids do better in mixed ability classrooms than they do in single ability classrooms, right? Like homogeneous classrooms. Study after study after study shows that. Yet we continue to stream. And in some places around the world, we stream like in grade 5. I actually was at the, never repeat this story. I was at the NCTM conference, which is this big national council of teachers of mathematics in the States. They write all kinds of books and publish journal articles. I mean, they're the gurus of math, right? And I happened to be at a bar, because that's what you do when you go to conferences. That's where you meet people. You know, you socialize, talk about math. And I was talking to this guy.
Always.
Whatever. That's what I do. It's my idea of fun. Margarita and some math. And I was talking to this guy, and he's talking about this presentation that he'd been to that day, where the presenter said, you know, if we would just stream kids based on grades and not race and socioeconomics, we would actually have more kids, you know, from marginalized communities being in the higher streams. And I was like, looking at him and going, well, if we didn't stream kids at all, wouldn't we have all kids in the higher stream? And he's like, oh yeah, I know, it's a shame that we're doing these testing at grade 5 and streaming them into different classes. But you know, it's just the way it is. This guy is the president of the NCTM. So I spent the rest of the night kind of explaining to him how streaming was bad, as we went from bar to bar to bar. In Washington, lovely place, lovely place.
I don't like to give the conversation by the fourth hour.
I was not drinking very much, but he was like off on something. I don't know. But it's frightening because there are a lot of people who still believe that it's okay to stream kids very early. In the British system, kids write exams and are streamed like into different high schools based on their scores at 12. Right? If I had to be judged based on what I did at 12, I'd be in trouble. Like a lot of trouble. Okay. Anyway, the point is, that's my little rant about streaming. I'll go off on that every now and then. Sometimes evaluation isn't about the kids, it's about what we're doing and how we can do it better. And we have to be open to that. We have to be aware that sometimes it's not them, it's me. And that's okay. Because from that, I will learn and grow. Okay? Sometimes it's about evaluating students and recognizing accomplishment. A lot of people think this is the only purpose of assessment. Right? It's not. It's actually a fairly minor purpose of assessment. Really, if I was queen of the world, I would have no grades at all. I would just focus on constant improvement. And sometimes we do evaluations to modify a program. Like, for example, we've heard from a lot of teachers that the current curriculum is too big. So we need to modify it and make it smaller, which is why we're bringing in a WNCP. So that is a very kind of perfect example of how we use assessment and evaluation. Now, most of what you will do, you won't be involved in this too much, not starting out. You may be eventually, you may get to pilot a program or something like that where you're actually involved in modifying a program. But most of what you will do kind of will focus on these areas. And the primary focus of assessment for learning is about promoting growth. And we want to try and do that as much as possible. help students to go from where they are to where they need to be. Okay. In your teaching resource documents, you know the ones I mean that are on your Moodle site that take the curriculum and organize it into units. Every one of those has a chapter 3 or section 3 on assessment and evaluation. Okay? And so this is the grade 2 one. And they talk about assessment for learning, assessment as learning, and assessment of learning. Okay? And they kind of talk about the assessment cycle, which is similar to what we did, but it's a little more linear. I like circles. It's because I'm a right-brained mathematician. And then it gets into different topics, but one of the things I want you to think about is questioning. Okay? We've talked a lot about the importance of talking. Discourse is a fancy word for talking or communication. But talking in math class is really important. When you can explain your strategy, when you can have a discussion about different strategies and how they relate to one another, you're thinking about your thinking, right? And it helps you to understand better. So the more we can have students communicating ideas, the better. So it gives you ideas in here about good question starters, right? Lots of good ways to think about, how can we compare and contrast? What kinds of problems can we do? Things like that. So it gives you some good ideas. But then it gets into levels of question. And this is what I was talking about earlier. And we have level 1, level 2, and level 3 questions. And I'm going to go back to the Smartboard slides in a minute. But I just wanted you to see that these are here. And it gives you kind of examples of what each one is. And down here, there's a very important breakdown. And it says level 1 should be 25 to 30% of what you do. Level 2, 40 to 50% of what you do in terms of testing and assessment. Okay? And level 3, 25 to 30%. International studies show that kids who work primarily on level 2 questions in their class time do best on international assessments. Okay? So a lot of our time should be focused on working on level 2. And I'm going to tell you what those are all about here in just a sec. Okay? A level 1 question is simply recall, define, calculate, explain, determine, whatever. Okay? It's give an example of a triangle, or tell me a property of a square, right? Calculate a fact, like 7 plus 6 is what, right? So those are level 1 questions, and they're pretty straightforward. They're basically one representation or reading information from a graph, things like that. So they're kind of like skills stuff, right? Your mental math facts, your calculation strategies, right? Although sometimes your calculation strategies might be level 2 if you're asked to explain them, but your mental math facts and stuff like that are level 1. So it's basic stuff that you can quickly recall. Okay? Level 2 is all about understanding. Level 2 is about showing that you understand and that you can explain, demonstrate, apply. Okay? So a lot of what we do with level 2 is about making connections or switching representations. I'm just going to draw you a little graphic here. I think one day we talked about the fact that we have different kinds of models. We might have symbols, right, or symbolic representations. We might have verbal, which is explanations. We might have pictures or pictorial representations. We might have concrete models, which is our manipulatives and things that we build. And we might have contextual models. Have we talked about this before? Because I never remember what I tell you and what I tell my other class, so sometimes I forget. Yeah. So anytime I switch representations, as I go from one of these to the other, I'm doing a level 2 kind of task. And real understanding comes when we have flexibility to move from any one representation to any other representation. So we want to make sure that we ask a lot of questions where kids are asked to, explain a picture or give the symbol for a picture, right? So if I showed you a number line model, could you write a multiplication sentence that modeled it, right? If I gave you a number line model for multiplication, could you tell me a story problem that modeled it, right? Can you build me a concrete model for symbolic equation? Can you build it with concrete materials? Can you explain what you did and tell me a story problem where you would have to do that, right? So what we want is for kids to be able to do all of these different representations. So if we're spending a lot of time getting them to apply, to switch representations, okay? Making inferences and generalizations. So can you predict a rule based on what you did? Right? One thing that we might do now that we know how to find chickens and horses, if I gave you new numbers, would you have a good strategy? Right? Could you make a general rule about that? And you might be able to. Okay? So international studies have shown that kids who spend a lot of time doing level 2 tasks, comprehension tasks, actually do quite well. They develop a deeper understanding because when you can make connections, you have more understanding. Okay? If you're just recalling facts, you might have all kinds of facts, and we know all kinds of people who were really good memorizers and memorized all kinds of stuff and got their way through maybe first year calculus, or maybe not. Right? First year calculus has a very high failure rate because memorization isn't sufficient anymore. Right? And there's some kids who can memorize their way through high school, and then they get to first year calculus and they're like, oh my God, I don't know anything. Right? So we want kids to have understanding, not memorizing. Okay? Level 1 is about memorizing. Level 2 is about understanding. It's really about switching representations. Okay? And then level 3, we already talked about a little bit. So it's multi-step, multi-concept, multitask, non-routine problems, requires application of problem-solving strategies, and it's new and novel applications. So it should be stuff that you haven't seen before. Unfortunately now, if I gave you another problem about chickens and horses, it's not level 3 anymore, because you kind of know how to do it now. Now it would be level 2. It would still be a story problem and you have to apply it, right? You have to solve it, but it would be level 2, because now you know how to do it. It's not going to require you to think creatively anymore. So it's good to have banks of level 3 questions because they're hard to come by and good to use. Okay. So here's some examples of level 1, level 2, and level 3 for multiplication. So I might ask you, multiply 5 times 4, right? That's a level 1 question. You just need to give me an answer. You don't need to give me an explanation. You don't need to draw me a picture. You just need to say 20. Right? Or I might give you something like the second one. If 3 times 4 equals 12, then 4 times what equals 12? And that's just to see if you know what commutativity is. Right? So you're just filling in the blank. Okay, it's an open sentence, you have to fill in the blank. That's a level 1 question. It's pretty straightforward. I'm just checking to see if you know that information. So when you think about level 1, it's really just checking to see if they know kind of basic information about things. Okay. Level 2, well, this is an example of level 2. What multiplication is shown by the picture below? So I'm taking a picture and I'm asking you for a symbol. I'm switching representations, right? Another one, draw a picture to show a way to find the solution to 8 times 7. Okay, so you might draw 10 frames because you love those now, and you're like all about the 5 and the 2. Or you might just draw an area model, or you might draw, sets of 7 or whatever. This is a word problem. It's important that we don't confuse word problems with level 3 problems. Right? Level 3 are non-routine problems. Most word problems are just level 2. It's taking a context. They're contextual stories. So it's taking a context and applying symbolic or pictorial strategies to solve it. So Kevin wants to make treat bags for his party. He needs 8 bags. He wants to put 14 pieces of candy in each bag. How many pieces of candy will he need to make the treat bags? Okay? That's not a level 3 problem because it doesn't require any problem-solving strategies. It's just a story problem. We often call them contextual stories, not so that they don't get confused with actual problems. Okay? This, however, is a problem. The grade 3 class is making Valentine's treats for the whole school. They make heart-shaped sugar cookies and round chocolate chip cookies with red frosting. They want to make sure that they have one of each treat for each of the 114 students and 6 teachers in the school. They have cookie sheets that will hold 5 rows of 4 heart-shaped sugar cookies or 6 rows of 5 chocolate chip cookies. How many pans of each cookie do they need to make? Okay? This problem is multi-step, multitask, right? You're going to have to use some tables. You're going to have to use some tables to organize it. You're going to have to use some problem-solving strategies to think it through. You might have to draw pictures and models, or you might act it out. That's another good, right? You might just start building your own little pans of cookies using little counters or something. Okay? So this is a level 3 problem, which is multi-step, multitask. Okay? So what I want you to do now is I want you to grab a laptop or a curriculum document. We don't have enough curriculum documents over there, so I brought the laptops down so you can get the online ones in your Moodle course. And I'd like you to pick a couple outcomes and look at them, and then try and write 2 level 2 questions and 2 level 3 questions for one outcome. Okay? Don't worry about writing level 3 because they're hard to do. Okay? But try to write 2 level 1 questions and 2 level 2 questions for an outcome. Okay? So if you want to take a quick break, you can do that. Then grab a laptop or grab a curriculum document over there and take about 15 minutes or so and make a couple questions.